Back to the channel. Today we're diving into the fascinating world of turning points, those pivotal moments that change everything. Stay tuned to discover how these key events shape our lives and history. Let's get started. So the turning point occurs when the curve of a function changes its direction. So we see this graph here, it's going up and then down. The moment where it changed from going up to down is called a turning point. Similarly here on the right, we're going down and then up. The moment where it changed from going down to up is the turning point. And this is associated with a local max and a local min. So the first point over here, we're going up and then down, that's called a local maximum. And then going from down to up, that's a local minimum. And you can also think of this as these points are where the derivative is equal to 0. You cannot say that since the derivative is 0, it's automatically a turning point, but a turning point will have the derivative to be 0. Now for linear functions, they don't have any turning points. As you can see on the graph here, it's constantly increasing. There's no change in direction. It's going always up. So there is no turning point. For quadratic functions, whether we have something that's concave up or concave down, there is going to be a turning point. In the graph above, we're decreasing and then increasing. So at 0, it changes from decreasing to increasing. That's a turning point. And similarly down here, it's increasing and decreasing. So at 0, it's also going to be a turning point. And so for quadratic functions, the turning point is also the vertex of the parabola. Now for higher degree polynomials, let's say if a degree n, the maximum number of turning points is going to be n minus 1. Now for odd degree, the minimum is 0 and the maximum is n minus 1. Either way, it's going to be an even number of turning points. And for an even degree polynomial, the minimum turning points is 1 and the maximum is n minus 1. And the number of turning points is going to be an odd number. And that concludes our turning points.